Okay, so how to use the constitutive driver as I modified the path from Matteo. The driver itself is basically just uses the same function as the one Matteo produced. The main difference is that instead of defining manually the material parameters and the stress path within the code, what you do is you use the CSV file you can find in the material folder. You create one file for each material, and in this file you define each individual parameter, and it doesn't matter what column it's put on as long as the header name for each column is correct. So if I move MF in the end, it will still work. And the other one is the load paths, XLSX, which you cannot keep open while you run the simulation because it's an Excel file and Excel doesn't like that. In any case, the way this works is you define a name for each stress path. For example, this is triaxial one. You define the number of steps, NS step, and the I code, which defines the way the load or the condition, the boundary condition of the individual step. And you have to define this based on what you want and based on the border metrics here in the first um, sheet, which you don't have to edit, contains the list of the different stress or load paths. And then using this image here, you can decide what you want the two variables to be, A and B. For example, you can see here it's a triaxial. So first you have stress controlled to triaxial compression. Number of steps is just how many times you want, how many steps you want to this. Since it's stress controlled, what you input here as condition is directly the stress in kilopascal, and then the two variables you can are equal to -1, which you can see here stress controlled to triaxial are A and B in the matrix here equal to 1, which means it's isotropic compression, or -1, which is isotropic compression. And in the second step, it's mixed controlled standard triaxial compression, which means you keep the stress, the confining stress, constant, in which case it's the one from the previous step. So in this case, it's 100 kPa, and it applies the axial strain up to 0.25, so 25%, and these are just says just to keep it this way. This, for example, is another triaxial, which is the same but initial confinement at 400 kPa. And for example, this is an UCS, which means you first apply a modicum of confinement, so just the material doesn't have convergence issues. So miscontrol standard compression up to 0.25 with no, with zero lateral confinement, and then into the actual confinement, the actual test. And that's all there is to it. The file just uh, extract material parameters from the one Excel. It extracts the load path from the other Excel, and for each load path and for each material, it will run the element test and then save this into both txt files for each result, as well as one Excel with all the individual, well, it's basically the same txt, but all in one Excel on different sheets of this Excel. For example, this is UCS all sheet, so you have stress invariance, strain invariance, stresses, strains, plastic strains, active variable, and yield variables. and that's all there is to it.